Okay guys, I think we can start today's session. Okay, so last class we have been discussing about the basics of rows concepts like rows topic, then rows service action, then parameters, all things like we have been just following the rows 2 tutorial. Okay, so today also we are doing the same. We are going through the official rows 2 tutorials, and if you remember, we have been following this. These are the set of tutorials available in the official website. Okay, I'm just sharing it. So we have gone through these things like configuring the environment and turtle sim, then understanding the nodes. Understanding the nodes means like we can start the nodes, and using rows 2 node list you can list out the nodes, then topics, services, parameters, action. Okay, and launching the nodes that we can see next. Okay, after that we will be starting with like how to create a rows workspace, and then how to create a package, or how to build an existing package, then how to write a node. Okay, how to write a first hello world program, like basically a publisher and subscriber. Like we already know the talker and listener program, right? So we can see how to create a new package and then put all these program on it and then build it and run it. Okay, so these are the things that we are going to see, mainly the beginner client libraries. Okay, so we mostly done with the beginner CLI tool section. Only the launching of nodes is remaining. So launching of node means we can see how the launch files in rows 2. Okay, we will see I mean some demo launch file. After that, when you discuss the packages, after discussing the package, we can discuss in detail, because the launch files in rows 2 it's totally changed. Okay, it's totally changed. It's basically now we are mainly working on a Python code. Okay, Python program for launching the nodes. Okay, there are different methods, but the popular method is the launch file is like a Python program. Okay, so first we can see the launching of the nodes. Okay, we can see a demo launch files to get an idea. So you can click the launching multiple nodes from the tutorial, this one. Okay, launching nodes you can take, and then you can see this command, right? Rows 2 launch turtle multisim dot launch py. Okay, basically instead of rows launch we have rows 2 launch. Okay, rows 2 launch and the package name and the launch file. So in rows 1 we have dot launch files, right? If you remember, we have dot launch files. In rows 2 primarily we have .py files. Okay, we can write in YAML file and also in XML file, but the .py is so powerful. Okay, because it's like writing a code. Okay, like we can program the launch file. Okay, so this is the most powerful part of rows 2, because I don't know, like you have worked with big projects in rows 1. One of the main problem is that if you are launching tons of nodes, maybe 20 or 30 nodes, and if you want to launch some nodes maybe after launching a set of node, mainly like I'm talking about, like if you want to implement some kind of flow, like after launching 5 nodes we can load another set of node. So these kind of programmatic things can be implemented using the Python launch file. Okay, but there are limitation in the dot launch files in rows 1. So those limitations are overcome by the latest version of launch file, which is a Python file. Okay, so this is a demo Python file that we can see here. demo Python launch file. Okay, so which is inside the TurtleSim package. Again, TurtleSim is giving a demo launch file to learn. So this is a demo file, which is basically a launch file will have a function called generate launch description. Okay, it's not like a regular Python code. It's basically it is having set of modules, launch modules. Like there is a Python module called launch. From that we are importing a thing called launch description. Okay, so these all are the launch modules in Python. Okay, and we are importing that. Again, launch rows.action, we are just importing these things. And then what we have to do is for writing a basic Python based launch file. So here they are running two nodes basically. Okay, two nodes. So if you remember the rows1 launch file, maybe I can simply take the rows launch to give you an idea. So the rows launch, oh, it's not here. I hope you remember, like within the launch tag we are including the we are including the launch files. Then we can start a node using the node tag. Okay, this is how we are starting a node. So similar to that, in this scenario we are going to start two nodes. Okay, so when you launch this command, okay, we can launch it first. It's basically starting two nodes, and what it is doing is it is starting two TurtleSim instance. Okay, starting same node with different namespace. Okay, different namespace means maybe I can show you the output of this, and then you will get an idea. Okay, what I'm doing is I'm taking the terminal, dividing it, and then press Ctrl and scrolling the mouse to increase the font size. Ctrl and scroll the mouse, and then copy pasting, press enter, and you can able to see there are two TurtleSim. Okay, two TurtleSim. I'm just minimizing it, and let me check the topics. Rows to topic list. You can able to see these two turtle nodes are separated or differentiated using a namespace. Okay, this can be do in rows1 as well, or you can give a different node name or something. So here you can see we are starting the executable called TurtleSim node, okay, from a package called TurtleSim, and we are giving a namespace called TurtleSim1 for the first node and TurtleSim2 for the second node. Okay, so how we are starting the node, there is a difference in starting the node. What we have to do is there is a function we have to fill. So the function called generate launch description. Okay, this is a predefined or an existing function, and this function will be calling whenever we start a launch file. Okay, and what is it returning? It's actually returning the launch description. Okay, so the launch description is what we have to describe. The launch description is what are the nodes it has to start, what are the launch file, sub launch file it has to start, then what are the parameters file it has to load, then lot of stuff that we have done in the other launch files in rows1. All the things can return using the launch description. Okay, so launch description is basically a module you can see here. So we have to return a launch description module or launch description object, and this function will be returning that, and inside that we have to fill these things. Like we have to use launch rows.action node. This is for adding a node. Okay, and if you want to add another node, just put comma and add the same syntax for adding a node. Okay, so in order to start the node, we have to do up to this. Okay, I'm not describing everything on the launch file. This is like a demo launch file. I'm just describing the style in the new launch files. Okay, so this is the style, guys. We have to give an array inside the launch description module or launch description class, and this array will be processed and then it will be launched. Okay, so in order to start the node, we have to give the set of nodes that we have to launch, so it will be launching. Okay, so this is a very basic launch file, and the launch file will be launching, and you can see the topics. Okay, you can see turtle sim command velocity, color sensor, pose, command velocity, then turtle sim 2, turtle 1 pose. So these two instances got created. Okay, and you can interact with each turtle sim using these topics. Okay, when you press Ctrl C, these two turtle sim will go, and this is the demo launch file that we can find from the turtle sim package itself. So the turtle sim package is having almost everything. Okay, like the demo for action is there, launch file is there. I mean, most of the stuff are inside the turtle sim package. And if I remember correctly, in ROS 1 also there was a launch file to start something in the turtle sim package. So turtle sim is like a reference package that you can take. It is having everything. So if you simply search for turtle sim ROS 2 package, 1 second, let me see where it is. Showing some other packages. Yeah, it's not. Okay, let me switch to the humble level. Okay, so I think this is the package. Yeah, this is a package. Okay, I'm just sharing the code. So you can find you know how a package looks like, right, in ROS 1. So the same, almost same, I mean the style is for ROS 2 packages. Inside that you can see the launch file that we have started, multisim.launch, inside the launch folder. Then inside the src folder you can find the cpp file. Then action, inside the action folder you can see a definition of action message. Then in the msg folder you can see the ROS message definitions using in the turtle sim. Then in srv the service definitions. Then in the tutorial I think like some cpp examples, okay, for working with turtle sim. And in include there are some header files, and yeah, and there is package.xml, cmake.list, and this is for the change log. It's for the GitHub. Okay, so this is for like the icons and all. I think yeah, that is for like keeping the icons of the rows. That is not required for us. So I'm just mentioning like the turtle sim package is having demo stuff, demo for all the things. So we can refer this package for checking how a package, demo package looks like. Okay, and yeah, so here they also demonstrated how to control this turtle independently. So maybe I can show you that. There is no big deal. because we have separate topics for command velocity, TurtleSim 1 command velocity and TurtleSim 2 command velocity. So in this tutorial, what they are saying is it is publishing command velocity for TurtleSim, and in the second terminal it is publishing the command velocity for TurtleSim 2. Okay, so I'm simply copy pasting the command. So you can see we are using rows2 topic pub, then topic name, message type, and inside the braces we are filling the rows message. Okay, and if you enter, it's keep on publishing. You can see one turtle, that is TurtleSim1 is rotating, and I am publishing the second one. 1 second. So you can see the TurtleSim2, it's again rotating independently. Okay, so they basically demonstrated how to work with two turtles and how to start two TurtleSim, or how to start two instance of the same node with different namespace. Okay, so that is what it's showing. And in the next or the last topic in the CLI tools, they are talking about rows bags. Okay, which is very, very important in while working with rows. I hope you all aware of the importance of rows bag. So if you are in a university, or if you are working in a company, if you are working on a real robot, then there are some limitations, right? Like if you want to build some applications on the robot, you need the actual hardware always, right? So using rows bag, what we can do is we can record the data from the robot, okay, or a robot sensor, and then we can take it out, or you can copy that back file, and then you can play that back file on your computer. Okay, so it will avoid the hardware dependency. Okay, and you can play and create your application, robot application, using the recorder file. Okay, so here they are demonstrating the rows bag. It's basically the same. In rows1 we have been using rows bag command. In rows2 we are using rows2 bag. Okay, rows2 bag record and rows2 bag play. Okay, so they have demonstrated how to bag a topic. Okay, maybe we can do an exercise. So first, maybe I can just move. Okay, let me clear the terminal. Okay, so first I'm starting a TurtleSim node. Here it is, and then the next I'm planning to start is the Teleop. Okay, 1 second. Okay, I have started. So now I can able to move the robot, or move the turtle using keyboard. Okay, and now what they are saying is like if you want to bag a topic. Okay, so now if you check rows topic list, you can find a set of topics, right? Command velocity, then pose, then all these topics that you can see, right? So if you want to bag some topics, okay, maybe what I can do is I'm simply resetting the turtle for One second. Not kill, reset. Okay, I'm simply resetting the turtle. Okay, and I just want to bag the command velocity. Okay, command velocity. So for example, if you echo the command velocity, you can able to see when you move the robot, the command velocity is changing. Okay, command velocity is changing. So I just want to bag this topic. Okay, just want to show you the working. Okay, I'm simply creating a folder called bag in the home folder, and then I'm using the command called rows to bag record the topic name. Okay, so what was the topic name? It's turtle. One second. Rows to topic list. Okay. Okay. So I'm starting recording. Okay. So currently this topic is getting recorded. So what I'm doing is I'm just moving the robot using the keyboard Teleo. So you can see the robot is moving, and these command velocity, okay, these linear and angular velocity is getting recorded. Okay, it's getting recorded. Okay, that's it. So now I'm planning to stop the recording by pressing Ctrl C. Okay, the recording got stopped, and I'm also stopping the keyboard teleop and turtle sim for now. And let's play the back file. So I'm just starting the teleop, not teleop, turtle sim, and then we can see whether the back file is got created or not. Okay, so I'm just typing ls, and you can see there is a folder just created. Okay, which name rows back to and some dates. Okay, so what I'm doing is I'm trying to play it, rows to back play, and one second. I'm just copying this. Yeah, I just want to give the folder name, and you can able to see the turtle is moving similar to the command velocity that we have recorded. Okay, and yeah, it's actually same, right? So this is throws back, like you can able to record and play. Okay, and there are different things that we can do with the rows back. You can increase the speed, then decrease the speed, all these things that you can do. Okay, very useful tool, guys. So I just mentioned about the recording. Okay, so now we can jump into the main topic, which is the packages, workspace packages, how to build the packages, all those stuff. Okay, so you can take the beginners client library. So this section is talking about that topic. Okay, so first we can start with creating a rows workspace. Okay, rows workspace. So before that, I just want to talk about the build tool. Okay, in a very easy manner. So in rows 1, we have used the catkin make Catkin make, right? In order to build a repository, in order to build a workspace. I think you remember it, right? And in ROS2, we are using a new tool, okay? A new tool called CallCon, okay? So it's like an iteration of Catkin make isolator, then Catkin build, and then Amen tools. Okay, so these all are the previous build tools available, and CallCon is the newest one. Okay, so CallCon is what we are using in ROS2 to build the workspace. The workspace will include mainly the packages. Okay, so when you install ROS2, I'm just going with the installation. If you just scroll down, you have seen this command, right? After installing ROS dev tools, okay, ROS dev tools. And this tutorial says we have to install Python 3 CallCon common extensions and all. Okay, in order to get the CallCon, we have to install this. So I'm just taking the Synaptic Package Manager. I think you all know what is a Synaptic Package Manager. And I'm just searching for ROS dev tools. Okay, ROS dev tools. Okay, here it is. We already installed it. And then if you right click and check the dependency, you can see Python 3 CallCon common extension. Okay, that is what we are seeing here. Okay, meaning when you install ROS2 and when you after installing Humble, if you install this package, then all the build tools required for building the ROS2 packages will be getting installed. So we don't need to execute this command. Okay, it's already installed. Okay, for understanding this, you can simply copy this and again search here. You can see this got installed. Okay, it's already installed. Okay, so CallCon tool is installed. Now it's a time for creating the workspace. So they have mentioned how to create a workspace. We can simply follow it. You can also try. Okay, so the process is almost similar to the ROS one. I'm not sure you remember it. So it's simple. In order to create a workspace, what you have to do is you have to create a folder. Okay, 1 second. So the folder name ROS2 workspace, okay, /src. Okay, so inside the minus p means mkdir means creating the folder, or if you are lazy enough to type the commands, just create a folder. Okay, ROS2 workspace. Okay, ROS2 workspace, and inside that create a src folder. That's it. Okay, you have created a workspace. That's it. Okay, so now what is next? So after creating the workspace, what is next? Obviously putting the packages, creating the packages, right, and building the workspace, right? So before creating a new package, we can start with an existing package. Okay, like we are just downloading an existing package, and we gonna build it. Okay, that is what we are going to do. So in this tutorial, we can see there are some example package available in the GitHub. Okay, so using this command, you can able to clone that example. Okay, so that is what we are doing first. So we have to be in the workspace folder and then clone it. And then if you just go to the SRC folder, you can see examples. Okay, examples. Okay, so this is a demo package, or like you can say an examples package. Name is examples itself. No, not example. This repository having multiple examples for ROS2 CPP and ROS2 Py. So these all are the examples. There are multiple examples available here. Okay, so this is for C++ and this is for Python. Okay, so I mean, these examples are basically programs. So if you just simply go to topics, then minimal publisher, you can find a different ways to publish a topic. Okay, there are 4 or 5 methods to publish a topic. Okay, we will be seeing mainly one, but you can from this repository. Okay, from this repository you can able to able to see all the ways to create a publisher, subscriber, then service, server, then action, parameters. All the examples are here. So what I'm trying to say is this repository is enough to learn ROS2. So you can see there are like 535 stars. Okay, you can play with all these things. Okay, and there are launch examples is here. So mostly like the tools required to start with a project is here. Okay, now you can think about the project ideas. Okay, so everything is there. So now what is next? The next thing is we have to build the repository or the workspace, right? So we have clone a existing package. Now going to the workspace root folder, and then in ROS1 it was catkin make, right? If you remember, it was catkin make. In ROS2 it is colcon. Okay, colcon build. Okay, colcon build. And if you are only working with C++, colcon build is enough. But if you are working with Python as well, I will prefer you to do symlink install. So the symlink mainly help you to change the Python file from the SRC folder. Okay, like even if you change the Python code, you can able to run it. Okay, maybe I can explain it after the build command, so you will get an idea. So this is the build command that we are using, and currently if you check the workspace, there is only SRC, right? So if you do colcon build, so colcon build simply fine if you only have C++, but if you have mixed package like it is having Python, C++, all the things, I will say symlink install will be good. If you press enter, let's see, it start building. Okay, there are 22 packages. Actually the example repository having multiple packages, so I think it will take a lot of time. Let's see, let's wait for some time. Yeah, I think it will take a lot of time. Let's see. Okay, if it is taking a lot of time, maybe I can take only one package from the ROS RCL CPP. I think it will take time. Yeah, maybe example RCL minimal subscribe, but I think we need all. Yeah, only three packages got completed. Okay, so here,
It's taking a lot of time. When I started parallelly, it's taking a lot of time.
yeah, because like this repository is having lot of C++ code. So if you
Okay.
check these RCLCPP folder, there are a lot of code actually, example code. So the Qualcomm build will be building all the package at once, but we can specifically build individual packages as well. There is an option for that, but I think it's better to build all the package now, and yeah, let's see. It will take some time. It's actually doing parallelly, like you can see four process or four concurrent building is going on, but again, like it will take some time. um, yeah, so when you build, you can able to see there are three additional folders got created. So one is build, and that is having the same functionality of the build folder in the ROS one. Okay, in the ROS one, the build folder is having the CMake, intermediate file. When you build a CMake base package, all the ROS 2 packages are based on CMake. Okay, mainly the C++ packages. So um, so the CMake list intermediate files are storing the build and the install folder. Okay, so in ROS 1 it was devel, in ROS 2 it is install. So in install, all the executables getting installed. Okay, all the executable getting installed, and in the log folder we can see the latest logs and all build logs. So these are the three folders mainly it's creating when we are using the Qualcomm build. Okay, now it's almost going to finish, like 20 out of 22, and after that we can see how to run it. Okay, 1 second. So currently it's processing example RCLCPP minimal subscriber and minimal subscriber mainly. Yeah. And after that they are running the demo, and then next instructions are like to create the package, create a new package. Okay, so yeah, so if we have time, I can explain another thing. So there is a difference, if you are working with a Python code. Okay, if you are working with ROS Python code, we have to build that Python based package using a build type called amen Python. If it is CPP, it's amen CMake. So like when you create a package, we have to give what kind of build types that we have to use. Okay, so I am just saying this because this will be useful when we start creating the package. Okay, and if you are planning for a Python based package, meaning if you have Python code, then you have to go with amen Python. Okay, yeah, that is the method, and I think we can also add CMake into that package if we have a mixed like Python and CPP code. Yeah, okay, so I will come into that. So first we can check whether the build is successful or not. Okay, the build is successful. So the next thing is that we have built the package, right? We didn't source the package yet. So what is the command for sourcing? Sourcing command is the same, the workspace. So instead of devel, we have to do install setup.bash. Okay, so this is the command to source the workspace. So what is the purpose of sourcing? The sourcing will like help to find the packages inside that workspace. Without sourcing, we can't able to access the packages inside the workspace. Okay, so for example, in this workspace we have a lot of packages, right? If you are not doing the sourcing, then you can't able to access that package, or if you are using ROS run or ROS launch, you can't able to access it. Okay, so in order to make a permanent sourcing, you can use the bash RC. Just go down and then you can use like this, ROS2 workspace install setup.bash. Okay, save it and do a sourcing again. Okay, so if you type bash on the terminal, it's basically sourcing, or it is running the .bash RC file. Okay, and now you can start executing the nodes inside that packages that we have built. ROS2 run, then the packages are like examples, RCL CPP minimal, subscriber member function. So this is a subscriber, and we are running the publisher now, ROS2 run. The package name is examples. So the package name is actually based on, you can see here, they have done in a such a way that this okay, so minimal, this package, okay, so this package name will be, so if you check the name of this package, it is example RCL CPP minimal subscriber. Okay, so the folder name doesn't matter, the name that matters is the package.xml. Okay, and also it should be same in the CMake file. Okay, so same thing that we have seen in ROS1. So here you can see the package name is subscriber, and now we have another package, RCL CPP. I mean, don't worry about the package name, they have assigned this package, examples RCL CPP minimal publisher, then publisher member function. So you can see here, it's basically a Talkrine listener, hello world, it's simply printing, and then I am starting the RQT to see what is going on. So the minimal publisher is here and minimal subscriber is here, and the topic name is topic itself. Okay, the name of the topic is topic itself. You can I mean, we can give like that. So minimal publisher is publishing a topic called topic. Okay, don't confuse with the name, and it is subscribing by the minimal subscriber. Okay, yes, so this is what happening with the publisher and subscriber. Okay, so what we have done was we have built a set of packages using the build command, which is callcon build. Okay, callcon build was the main command that we have used, and after building we have done the sourcing and then tried this demo. Okay, so if this demo is working, that means the building process is okay and sourcing is okay. Yeah, so everything is okay. Okay, now we have an important tool called callcon CD. Let me try to set that first. I'm not sure it will work fine, but maybe I can discuss that later, but let me try to demo that now itself. 1 second. Okay, Qualcomm CD turtle sim. Let me see whether, okay, it's working. It's working. I will explain, guys, no worries. Let me get another name of the package. Let me see it is working. Qualcomm CD. Okay. Got it. Maybe I can explain, which is a very useful tool. Okay. I will explain the creation of package after this. So you maybe heard about the row cd command in ROS1. Okay, I'm not sure you have used that or not, but you may be aware of that command. So what is the main purpose of the row cd? The row cd will help you to switch from the current path to the package path. For example, if I am doing row cd space turtle sim, okay, row cd space turtle sim, then it will be going to the package location. It will be going to the turtle sim package location. Okay, so instead of row cd, in ROS2 we have Qualcomm CD. Okay, we have Qualcomm CD, and by default Qualcomm CD is not working. Okay, it will not work. So in order to work with Qualcomm CD, you have to source these two things on the bash RC. Okay, these two things on the bash RC. So if you check the bash RC, you can simply copy paste. Okay, copy paste that command, and if you do the copy paste, you can able to see these two lines on your bash RC file. Okay, so this should be there in order to work with the Qualcomm CD. Okay, I think they will be like giving an update later, so we don't need to do this stuff anymore. Okay, so as of now, as per the instruction, we can do this. And what happen if we have the Qualcomm CD tool? If we have Qualcomm CD, and if you know the package name, for example turtle sim, it will be going to the turtle sim package. Okay, this is the package that I mean the turtle sim package is available. Okay, so what is the importance of Qualcomm CD? If you want to find a package, or if you want to switch to a package path, this is very useful for me. I used to use this package, this command, in order to detect, okay, a package is already sourced or not. This will only work, I think, mainly it will mainly work if you are properly source the package or source the workspace. Okay, so that's the thing, guys. So that is the Qualcomm CD. Okay, very useful command. And we have checked that. 1 second. Now we have some time to show you the creation of the package. Okay, let me see whether we have to discuss that tomorrow or not. Okay, maybe we can discuss the creation of new package tomorrow, because it is coming up with some more concept. Okay, so as of now, today, like, we have discussed how to 1 second, how to run the back file, then how to launch file, then what is Qualcomm, and how we can use it, and then how we can create a ROS workspace, and how to build using Qualcomm build. And then we have tried with an existing package. Then also we have checked the Qualcomm series. Okay, so next I will be like discussing about how to create a package, and then how to put the C++ file, how to compile it. Okay, all these things will be the next topic, and that we can discuss on the next class, which is tomorrow. Okay, so do you have any doubt, guys, like regarding the current topics that we have discussed today? If you have any doubts, let me know, and then we can conclude the session. Let me know if you have any question, guys.
Yeah, in ROS 1, we have make clean, like a cat clean, make clean.
Yeah.
Do we have similar here?
Okay, so the Qualcomm, I need to check that. I didn't try that before. If you simply, type the Qualcomm command, you will get the list of commands that is supporting. So build is there, extension point, graph, list, test, or only these things are available. I think the clean is not available. I'm not sure with the Qualcomm build clean. Let me just check. Maybe we can try it now. ROS2 workspace, Qualcomm build clean. No, I think that is not available. These list is only, the list of command that is mentioned on the help is only available. Yeah.
Okay.
Yeah.
Okay. Yeah. Thank you.
Yep. And any more question, guys? So using the Qualcomm build, if you type like this, Qualcomm build -h, that means you will get all the sub commands for the Qualcomm build. So we can also check if there is any clean there. So if you check, you can build a specific package. Okay, if you only want to build a package, that is possible. And there is Symlink install. I think we have used that. Then if you want to process number of packages parallelly, by default it is 4, but if you want to increase that to 10 or something, if you have a good CPU, you can do the parallel work. Okay, so that is there. And yeah, so you can find all these options from this. I'm not sure about the clean. There is an option that we are seeing, CMake clean cache. This may work. Yeah, these two commands may have an impact. Maybe we can try that. Mostly what I am doing is in ROS 1 and ROS 2, in order to clean, I will be simply deleting this folder, and then I'm doing the build again. That is what I am doing. But in order to do in using the command, I think this may work. The CMake clean, I'm not sure. Yeah, let's see. But it's not doing the clean actually. If you are doing the clean, it should happen immediately. It should like wipe out everything. Let me see whether it will have an impact after building it. Let's see. So in the meantime, if anyone having doubt, you can ask. Let me see the output after this. Okay, I'm not seeing any result. Maybe let me check the build folder. No, there is not much different.
Actually, I'm getting some errors when I'm I'm building this Concon build for examples. It's saying lot of errors it is throwing actually.
You have to build it from the rows to workspace path. Are you building it from the rows to workspace path? This,
Yes.
and if you do the Colcon build symlink, I think what is the error that you are getting?
It's saying so many, it is bombarding so many errors actually. I understand there are some packages are missing. Pip package something.
Are you working from Linux itself or?
Yeah, I'm working from this virtual box.
Okay. So you can post that error in the discussion channel maybe. Let me see what is the error, because if the installation is proper, then the Colcon will be properly installed. If the Colcon is okay, then I guess it will be, building the packages. Yeah, so you can post that issue in the Discord. Okay.
Basically, yeah.
Any more question, guys? Any more questions? Okay. So if you don't have any question, I think we can conclude for today. And tomorrow we will be continuing with the creation of packages and the rows nodes. Like basically we will see how the rows to C++ and Python node will looks like. Okay, so that is what we are mainly planning tomorrow. Okay guys, so thanks for attending. So see you tomorrow. Bye everyone.
Thank you. Bye.
Bye.